Hi, ladies and gentlemen. We are on section 10.1 of our notes, which starts on page 3. So we are going to fill in our video notes for exponent rules and scientific notation. So the first rule that we have is about negative exponents. So if you notice right here, it says a over b to the negative nth power is equal to b over n to the positive nth power. So you're allowed to change the negative exponent into a positive one by changing the base to its reciprocal. So remember, you got to do the flipping of your fraction, which you guys have gotten very good at, all right? All right, so you've got two examples right here. The first example is 3 to the negative second power. Remember, this is over 1, so all you have to do to this number is say that it is 1 over 3 to the second power. Or you could just say it's 1 over 9 because 3 to the second power is 3 times 3, okay? And then in this other example right here, I have to take this fraction and do the reciprocal of it. Well, the reciprocal of it is 3 over 2. So I'm going to take 3 over 2, and then once I do the reciprocal of it, this negative 3 is allowed to become a positive 3, just like this negative 2 is allowed to become a positive 2 when I took the reciprocal. Well, 3 cubed means 3 times 3 times 3, which is 27. And then 2 cubed means 2 times 2 times 2, which is 8. So your answer to this is 27/8, okay? Now, the next rule that we're going to talk about is the product rule. And remember that when you multiply your any numbers with exponents, if they have the same base, you can just add the exponents. So right here, when multiplying terms with like bases, add the exponents. So here, all I have to do is see that the bases are the same and my exponents are 5 and 8. So 5 plus 8 equals 13. So my answer is 3 to the 13th power. And remember, we did a whole discussion about why this is true. This means that you've got 3 multiplied by itself 5 times. This says you've got 3 multiplied by itself 8 times, so altogether you have 13 3's, okay? Now, in this next example, you're going to add 3 plus negative 5, but remember 3 plus negative 5 just means 3 minus 5, which is negative 2. So you end up getting 3 to the negative second power. However, we want to write this out as a positive exponent, so your answer is 1 over 3 to the positive second power, okay? All right, now the quotient rule says that when you divide terms with like bases, you subtract your exponents. So these have the same bases, you just do m minus n. So here, our bases are the same, they're still 3, so I just do 9 minus 2, which is 7. So my answer is 3 to the 7th power. The next example is a little bit trickier, however, because all you have to do for this one is still do 8 minus negative 2. However, this minus negative, remember, turns into a positive, so it's 10. So this becomes 3 to the 10th power, okay? And then the last rule says that when you raise a power to a power, you need to multiply the exponents. So a to the mth power to the nth power, you just multiply those exponents together. So here you're going to do 4 times 5, which is 20. Your base, remember, stays the same, so it's 3 to the 20th power. And then this one, you're going to do 2 times negative 4, which is negative 8. So you get 3 to the negative 8th power. However, we said that if you have a negative exponent, you got to do the reciprocal, so it becomes 1 over 3 to the 8th power. So this is 1 over 3 to the 8th power, all right? Make sure you come with questions about any of these rules if you are confused about anything that we just said. All right, so scientific notation practice. The first example that we have is write 3.72 times 10 to the 8th power in standard notation. So this means that you're going to multiply by 10 8 times. So every time, remember that you multiply by 10, you move the decimal place over, it becomes a larger number, so I'm going to move it to the right. So here's 1 10, here's a second 10, 3 10s, 4 10s, 5 10s, 6 10s, 7 10s, 8 10s. So I move it over 8 times, and then I fill in these missing values with zeros. So that means that my answer is 372,000,000, or I could just say it's 372 million. Okay, now this next example, you're multiplying by a negative exponent, which means that you're really technically dividing by 10. So here we're dividing by 10 5 times. So if I'm dividing by 10, my number is going to get smaller. So 1 10, 2 tens, 3 tens, 4 tens, 5 tens, I fill these in with zeros. So it's 0.000081. And then I put this 0 here as just a filler. Okay? All right, so now this time I need to write this answer in scientific notation. So the question is, how many times did I multiply a number between 1 and 10 by 10 to get this number? So the first thing is I have to figure out what number it is between 1 and 10. So the decimal place is going to have to end up being there. So I know it's 2.89, and I put the decimal place there because 2.89 is between 1 and 10. But the question is, how many times did I multiply it by 10 to get this answer right here? So let's count it. 1, 2, 3, 4, 5, 6. So it's times 10 to the 6th power. Okay? And then this one, to get this number between 1 and 10, the decimal place needs to be there. So it's 5.3. But I didn't multiply by 10. I divided by 10 because it's a tiny number. So the question is, how many times did I divide by 10? So I divided by 10 1, 2, 3, 4, 5 times. So this right here is going to be to the negative 5th power because I divided by 10 5 times. Okay? And then the next example says write 35 times 10 to the 4th power in scientific notation. Well, doesn't it already appear to be in scientific notation? It does, however, this is not between 1 and 10. So I need to move my decimal place over. So this becomes 3.5. So what I'm doing is I'm taking 110 away to make this smaller. I'm dividing by 110. So if I'm taking 110 away, it's got to get added into these 4 tens right here. So it's 10 to the 5th power. Remember, your coefficient and your exponent are going to go in opposite directions. So if your coefficient gets smaller, your exponent gets larger. If your coefficient gets larger, your exponent should get smaller. Okay? And then the last example that we have here is 0.026. I got to move this over 2 times, so it would become 2.6. The coefficient got smaller, the coefficient got larger, so that means that my exponent should get smaller, and since I moved this over twice, this goes down by 2, so it's 10 to the 3rd power. Okay? All right, so now we're going to talk about operations with scientific notation. So here are the steps for what you need to do when you are doing any type of operations with scientific notation. For multiplication, you need to multiply the coefficients, then add the exponents, and then adjust if necessary. Adjust means you got to make sure that the coefficient is between 1 and 10. The exponents are allowed to be different when you are multiplying. There's no rule that says that they're not allowed to be the same. So we can go straight to multiplying our coefficients. So when I multiply my coefficients, I'm going to multiply 4 times 6, so I get 24. Okay? Then I'm going to add my exponents. So this becomes 10 to the 8 plus 9, or the 17th power. Okay? So then, here's my issue. This is not between 1 and 10, so I got to move the decimal place over 1. So if my coefficient gets smaller, my exponent should get 1 larger. And that's my answer. Okay? All right, so now when you are doing division, same thing, you do not need to have the same exponent. So when you divide, you can just go straight to your division. So step 1, divide the coefficient. So I'm going to divide 3 into 1.8. Well, 3 doesn't go into 1 at all. And then remember, you got to put your decimal place there to line it up. But 3 does go into 18 6 times. So you get 0.6. So I divided my coefficients. Then I have to this is incorrect. Please cross this off and write down that you should subtract the exponents, because when we are doing division, you should do subtraction of your exponents. So when I subtract these exponents, I end up getting 7 minus negative 4. Well, this minus negative turns into a positive. So it really turns into 7 plus 4 because you're subtracting a negative. So this becomes times 10 to the 11th power. But I have to adjust because this is not between 1 and 10. So I'm going to move my decimal place right here over by 1. So my coefficient's going to get larger, which means that my exponent should get smaller. So that's the answer right there. Okay? All right, now adding and subtracting, this is where the exponents have to be the same. So this exponent is 4, this exponent is 6, they're not the same. So what I'm going to do is I'm going to decide, do I want to change my exponents into 4s or 6s? It's up to you. So I'm going to change my exponent into 4s. So I get to copy this down as 10 to the 4th power. Nothing is changing, okay? However, this right here needs to become times 10 to the 4th power. But if I make this smaller, that means I got to make this bigger. And if I made the exponent smaller by 2, that means that I have to multiply by 2 tens here, or move the decimal place over twice. So I end up getting 180 times 10 to the 4th power. Now that the exponents are the same, I can combine my coefficients. So I have to figure out what 180 plus 2.5 is. Don't forget to line up your decimals. So 180 plus 2.5 is 182.5, right? So I end up getting 182.5 times 10 to the 4th power. But this coefficient is too large, so I got to move it over 2 times. So this is going to get 10 to the 2nd power times smaller. So I move this over 2 times, which means that I have to adjust by making my exponent 2 larger. So this is my answer right here. Okay? Now for word problems, this piece right here is key. Make the problem simpler to identify what operation to use. So let's read through this. 2 objects are 2.4 times 10 to the 20th centimeters apart. I'm totally lost with this huge number. I don't understand it. I'm going to replace it with a different number so it's nice and easy for me. So I'm going to say 8 centimeters apart. Okay? A signal from one object travels to the other object at a rate of 1.2 times 10 to the 5th power centimeters per second. Same thing. This number is confusing to me. I'm going to replace it with a super easy number that's smaller than this one because this is to the 20th power and this is to the 5th power. So I'm going to try 2. Okay? How many seconds does it take the signal to travel from one object to the other? So now let's read the question again with our easy numbers. 2 objects are 8 centimeters apart. So we know the distance from here to here from our 2 objects is 8 centimeters. Okay, so we know this is 8 centimeters. A signal from one object travels to the other at a rate of 2 centimeters per second. So every second it goes 2 centimeters. How many seconds does it take the signal to travel from one object to the other? You should end up getting that the answer to this is 4 seconds, right? And the way we figure that out is just divide 8 by 2. It's so easy when you use easier numbers. So once you identify what the operation is, now you can go ahead and do your division. So let's go ahead and do our division. So this means that I'm going to have to do 2.4 times 10 to the 20th power over 1.2 times 10 to the 5th power. And when I divide 2.4 by 1.2, 1.2 goes into 2.4 2 times, and then you just subtract your exponents. So it's 2 times 10 to the 15th power, okay? All right, so now let's take a look at the next example. The 2010 population of India was about 1.16 times 10 to the 9th people. Cross it off, make it an easier number. I'm going to use 10 people, okay? The 2010 population of the United States was about 3.1 times 10 to the 8th power people. This is a smaller number because the exponent is smaller, so I'm going to cross it off and use an easier number, and I'll just say 7 people, okay? About how many more people lived in India than in the United States in 2010? So if there were 10 people in India and 7 people in the United States, then there were 3 more people that lived in India than in the United States, and you figure that out by subtraction. Again, it's an easy problem once you cross off the scary numbers and use easier numbers. Now that we've identified that we have to do subtraction, let's go ahead and subtract. So it's 1.16 times 10 to the 9th power minus 3.1 times 10 to the 8th power. And I need to get them to have the same exponent. So I'm going to create it so that they both have an 8 as the exponent. So in order for this to become 10 to the 8th power, this gets smaller by 1, so my exponent should get larger by 1. So it's 11.6 times 10 to the 8th power minus, this is already to the 8th power, so I don't have to do anything to adjust it. Okay, now all I have to do is do my subtraction. So let's figure this out. 11.6 minus 8.1. 6 minus 1 is 5. 11 minus 8 is 3. So you get 3.5 times 10 to the 8th power. And you don't have to do any adjusting because this is between 1 and 10. So our answer is 3.5 times 10 to the 8th power people. And this answer right here, we forgot to label our unit. It's 2 times 10 to the 15th power seconds. All right, I hope you have a wonderful day.